Welcome to In Class with Dr. Prince. Today we are going to learn about atoms and molecules, and these notes will go on to the pages as assigned on the daily agenda. Please make sure you refer to today's agenda to get the correct pages. By the time we finish this lesson, you'll be able to tell the difference between atoms and molecules. Your job is to take notes while viewing this presentation. Don't limit your notes to what you see on the screen. Instead, however, use the power of pausing and rewinding to include information shared. If you miss something, just rewind the video. You can also pause when you are trying to complete a thought in your notes. Let's begin. Atoms. Simply put, atoms are the smallest units of matter. Can you believe that something so small has the ability to bring into existence so many things around us? Think about it. Everything from the ant, the pencil in your hand, and even you are made up of millions and millions of atoms. Atoms are the building blocks of all matter. Atoms form the elements that make up all the substances of the world. There are currently over 100 elements known to man. We'll get into that later when we discuss the periodic table, of course. These elements combine into a variety of combinations to make so many different substances. You need hydrogen and oxygen to make up water. You need carbon, hydrogen, and oxygen to make up sugar. You need iron and oxygen to make rust. You need sodium and chlorine to make table salt. This list goes on and on. Some of these combinations are beneficial or helpful, while others can be downright dangerous. Let's take a deeper look at the atom. The atom, once thought to be the smallest particle, is actually composed of even smaller particles called protons, neutrons, and electrons. These subatomic particles, while the same for each element, are actually what help us to see how each element is unique from the other. Protons have a positive charge, while electrons have a negative one. The neutron has no charge, or what I like to say is neutral. The protons and neutrons make up the nucleus of an atom and are situated in a cluster in the center of the atom. Around the nucleus are electrons that are moving in a circular-like motion, creating a cloud. This electron cloud is different for each element. When an atom is in its normal state, the number of electrons matches the number of protons. Remember I said earlier that atoms are the building blocks of matter? Well, it's true. Atoms combine to make compounds and molecules. Compounds or molecules are composed of two or more atoms. Again, you must have at least two atoms to make a compound or a molecule. What makes a molecule different from a compound then? A compound has two or more atoms, but those atoms can be the same or different in that chemical bond. A molecule, on the other hand, has two or more atoms just like a compound, but some of the atoms in the bond itself are the same. Look at the examples. The blue and gray model is a compound because it has two atoms, but it's not a molecule because it doesn't have two of the same kind of atoms. However, the red and white model is both a compound and a molecule because it has at least two atoms, but two of the atoms are the same. In this case, we would call this particular model a molecular compound. Scientists and students are able to make models of compounds and molecules in order to observe and understand the molecular structure better. How are atoms and molecules the same? Well, they both are always in a state of motion. You can't see them without the proper laboratory equipment, and they are everywhere. They are different for a number of reasons as well. While you can break down a molecule into the individual atoms that create it, you can't do the same with an atom. Atoms can form the molecules, but molecules don't form atoms. Many atoms bond with other atoms and gain stability in doing so. However, molecules, bonded atoms, are stable enough to exist on their own. Of course, atoms are like ingredients. With just a few ingredients, you can make many combinations of new things. So as you can see, with only 118 atoms currently known to man, we can see tens of thousands of combinations created to make all the substances we see today. Alright, so that's it on our notes today. Check the agenda to see the atoms and molecules assignment that goes with these notes.